Hey there, educator, and welcome back to the Make Math Happen podcast. Today, we're talking about understanding math, negative numbers, distance, and value. In our last episode, we focused on making sense of rational numbers. We talked about why understanding what numbers represent has to come before operating on them. We grounded that work in value, in magnitude, and in position. Today, we're staying in that same space, but we're narrowing our focus to one of the most misunderstood ideas in middle school mathematics, and that's negative numbers. And to do that, we're going to spend some time with the tools students have been using for far longer than we often acknowledge, the number line. When students struggle with integers, it's easy to assume that this is unfamiliar territory. But the truth is, students have been reasoning about space and number relationships since the earliest grades. In kindergarten and first grade, students represent numbers as positions on a line. They count forward and backwards. They talk about more, less, closer, farther. They compare positions without ever using the word distance. By second grade, students explicitly represent whole numbers as lengths from zero on a number line. They solve addition and subtraction problems by moving along that line. They're reasoning about direction and change before we ever formalize those ideas. In third, fourth, and fifth grade, students extend that work. They use number lines to represent fractions and decimals. They reason about intervals. They compare values based on location. They estimate and assess reasonableness. So when we introduce negative numbers in middle school, this is not a brand new concept. It's an extension of work students have been doing for years. But things go off track when instruction starts to shift in a way that works against what students' experiences have been. When negative numbers enter the picture, we tend to abandon the visual model and replace it with rules. We teach things like two negatives make a positive, different signs subtract, same signs add. And while those rules might produce correct answers in the moment, they rarely stick. And that's why students can pass integer units one year and then completely fall apart the next. As a matter of fact, students can pass integer quizzes one week and the next week have no idea what you're talking about. The rules weren't connected to any meaning. What students needed wasn't another trick. They needed space. And I know y'all are used to hearing this word after we did a whole month on geometry. So I want us to think about integers as movement and not memorization of rules. Negative numbers make sense when students understand them as positions and movement along a number line. Positive numbers move us in one direction, negative numbers move us in the opposite direction. Zero becomes a reference point and a starting place. When students think this way, operations with integers become reasoning tasks instead of recall tasks. Instead of asking, what's the rule here? Students can ask, where am I starting and which direction am I moving? That shift is everything. This is where the geometry shows up again. Movement along a number line is geometric reasoning. It's about direction, distance, and location. The same ideas students used when sliding shapes or measuring lengths are now being applied to numbers. The math didn't change, the representation did. And this understanding pays off later. In seventh grade, this idea of movement supports multiplication and division of integers by helping students reason about repeated movement and direction instead of memorizing sign rules. In eighth grade, it shows up again when students solve equations with negative coefficients, when they work with exponents or interpret solutions in context. Students who understand magnitude and direction are far better equipped to judge whether solutions make sense. So, when we start teaching operations with integers, don't begin with rules. When I start teaching, I start with something that students know, something that they understand, something that we can build from. I want you guys to imagine that we're in a sixth grade classroom right now. So, I would have a number line drawn on either my slide deck or I might have it on my whiteboard. And the first thing I'm going to start with is something as simple as 4 plus 5. Most sixth graders are going to know this, right? So what I'll end up doing is I draw two arrows. One arrow is 4 units long. It starts at 0 and it ends at 4. The second arrow is 5 units long. I place it right after the first one, so it starts at 4 and it ends at 9. Some students need to show this with individual jumps, right? Instead of a single arrow, and that's okay. What matters is that they can see and keep track of the distance. We talk about where we started, how far we moved, and where we ended up. Then I go back and I change one thing. And I'm going to leave that first number line up so that they can see it and be able to compare it to the places that we're going. Okay. So next, I'm going to show them 4 plus -5. What changed? I'm now adding a -5 instead of adding a +5. Now the arrow for -5 goes in the opposite direction. We talk about opposites. We compare this sum to 4 plus 5. Same starting point, same magnitude of movement, different direction, different ending location. Students start to notice that the sign is telling us about direction and not necessarily just size. Okay. So when I move to 4 minus 5, this is where I'm going to pause. I don't explain, I wait. I'm going to give to students time to see the connection between 4 minus 5 and 4 plus -5. Some students notice it right away. Others need time to talk it through. We compare all 3 expressions that we've looked at thus far, and we talk about what stayed the same, what changed, why did 2 of them land in the same place? And students start to make those connections, and I make their connections visible. The things they share, I'm going to write on the board so that we can all see it. Because what we often don't realize is that even though we're having really good conversations in the classroom and it seems like everybody is with us, some people are just a second or 2 or 10 behind. And so the things that you're saying, although it's happening in real time, they're not processing it in real time. They need a little bit extra time, right? And so even though you're giving them quiet think time to reflect, you're giving them time to turn to their partners, you're talking about a whole group, you're capturing it on your whiteboard or wherever you're writing your notes, your anchor chart. It's really good to do that last part because when you capture it, when it's somewhere that it can live, students can take a look back. Students can reflect. And those who are not traveling mentally at the same speed that you feel like the whole class is traveling at, they have something to anchor them. So remember that as you go into next week's work, that collecting and displaying those student responses is a powerful move. It's a powerful move. All right, so we've done 3 expressions thus far. So I'm going to show them 4 minus -5. Now, we slow down. I want us to slow down here because I want us to connect it back to all the other expressions. We talk about starting point, direction, and movement. We talk about why subtracting a negative moves us in the opposite direction and why the ending location is larger than where we started. Across these 4 expressions, students aren't memorizing anything. They're reasoning. We talk about, again, where we started, the direction we moved, where we ended up, how far that ending location is from 0, and how the change compares to where we began. 4 expressions, 1 representation, that number line, but a lot of rich conversation. That's how students make sense of those negative numbers, distance, and value. After that, I give students time to practice, and many of them need to practice all 4 situations, not just one. If that's the case, I give them the space to do it. But the practice isn't silent and procedural. Students are talking, students are writing, students are recording their notices and their wonders. They explain what they see and why it makes sense. And that's where the understanding starts to stick. This is just one day. The next day, we could move into that first add in being negative. There's so many things that you can do with this setup. And Dr. Pamela Harris calls problems like this or situation or tasks like this problem strings. Okay. It's where you're taking one problem and you're kind of building from it and you're allowing those problems to kind of help students see connections and make sense of one thing to the next. It's helping to build their reasoning, helping to build their mathematical reasoning. Okay. So one of the most powerful ideas students need is this. Distance from 0 tells us about magnitude, not sign. So 2 numbers don't have to be on the same side of 0 to be close together, and they don't have to be on opposite sides of 0 to be far apart. What matters is how many units are between them. When students understand that, absolute value stops being mysterious. It becomes descriptive. And more importantly, students gain the ability to judge reasonableness. They can tell when an answer is too large, when it's too small, or pointing in the wrong direction. They don't have to rely on you, the teacher, or an answer key to validate their thinking. Now, I'm going to pause here to say there are some things that we definitely have to build in our classrooms to help students get to the point where they can validate their own thinking. Because one thing that is rampant right now is students are not confident in the math classroom. Unfortunately, they're not. Even some of our stronger students are still wanting constant validation and constant confirmation about where they are. There are all of these pauses where they're like, "Teacher, can you please check this? Teacher, can you look at this?" We have to build that confidence in all of our students for them to be able to have a thought about something, to be able to reason about something, and to follow that thought through. We have to build that within them. We have to let them know that they have power to come up with strategy. They have power to come up with solutions. They have power to come up with the best next step to figure out what it is that they need to figure out. This is really important that we build this thinking. It's really important that we don't continue this idea that we are the expert in the room. Because when we continue that, when that is what is present in our classroom, the students are going to continue to ask you, "Am I right? Is this right? Should I move on? Should I put it here? Should I put it there?" Yeah, yeah. If students are still confusing rules for integers in your class, it's not because they are careless. It's because we often rush past the meaning. We move quickly to symbolic manipulation before students have had time to reason spatially. And when that happens, understanding collapses under pressure. This is unfinished learning showing up, not lack of effort. It's not lack of effort. I know sometimes it gets frustrating when we're asking questions and students are scrambling, or students are not engaged, or they're not showing effort, or it doesn't look like they're showing effort. It's really they don't understand. That's really what it boils down to. They don't understand. So we have to take time to make sense of things. And I know we are fighting against these pacing guys. I understand that. But I want you to think about the difference it would make if we spent time going deeper and ensuring that students understand versus going wider and students barely understand anything. Okay. So slowing down doesn't mean stopping instruction. It means choosing representations intentionally. Today, I focus really on the number line because the number line has been a tool that students have used since kindergarten. So imagine a student walks into your sixth grade classroom, your seventh grade classroom, and they have 7 years of experience with a number line, with a tool. Why would I rob them of that? Especially if I know that they are having some difficulty with the concept. Why would I not allow them to use something that they know how to use? Hmm. So again, slowing down doesn't mean stopping instruction. It means choosing representations intentionally. Understanding math here means giving students opportunities to locate integers on a number line, to describe distance and direction verbally, have those conversations with those peers, compare values based on their position, predict results before calculating. Predict what is your sum going to be before you start calculating? What is your difference going to be? Where are you going to end up on that number line? Where do you think you're going to be if you could estimate? Have them do that. Explain movement instead of reciting rules. Even short daily routines can do this work. A single number line task, a quick notice and wonder, a prompt that asks what changed, what stayed the same. These moments compound. So tomorrow, when you go into your classroom, take a moment and see if you can try to make sense of integers using the number line. Choose one number line and one starting value. You can use something as simple as 6, and you can take them through the problem string that I shared earlier in this episode. 6 plus 7. Use arrows or jumps. Talk through where you started, how far you moved, and where you ended. 6 plus -7. What stayed the same? What changed? Why did the ending location move in the opposite direction? Show 6 minus 7 without explaining. Give wait time. Ask students how this relates to 6 plus -7. Then complete the set. 6 minus -7. Ask students to predict the ending location before you guys discuss it. Throughout the routine, keep the focus on where we started, the direction we moved, where we ended, how far we are from zero. No rules, no shortcuts, just reasoning. And have students write and talk about it. One thing they noticed across all 4 expressions, one question they still have, how direction and distance affect the result. This writing is really sitting heavy on me lately because I feel like one of the reasons why concepts and things that we've learned in class or things that I've intended for us to learn in class are so fleeting is because we're not writing as much. We know and I need to look up some recent research on this, but I know whenever I was a kid, they talked about how writing kind of gives you that extra level of processing, right? Hopefully if you're engaged while you're writing and not trying to listen at the same time, but just writing something down, you're naturally looking over what you're writing or reading what you're writing, and then hopefully you're going back and you're looking over it. We got to teach them how to do this because the students are not necessarily coming into our classroom knowing how to do these things, knowing how to take notes, knowing how to review notes, knowing how to study. They don't come to us with that. So we have to teach them. We have to teach them. So having a composition book where when you're going through these reasoning tasks, you have something that students can glue down in their book, right? Or you have some guided notes that they're going to add in there. And then have students take the time before you wrap up the day to think about the things they notice. Think about the questions that are still burning within them. Okay. It's critical that we do that if we want to change the direction that things are going in our classroom. If we want to change it, right? If we want to do something about the things that we're often complaining about on social media, about what students can and cannot do, what students can and cannot remember, we're going to have to do something different, right? We have to do something different. And I think that writing piece will be critical. I think it'll be paramount. Okay. So if students need more time, let them work through all four examples again using a different starting number. This routine builds understanding of negative numbers as movement and prepares students to reason about operations instead of memorizing rules. Once students have built an understanding of what happens when the first add-in is positive, do a string of expressions where it's negative. See if they can apply what they've learned. This extension reinforces that relationships stay consistent even when the location changes. Students aren't learning a new set of rules, they're applying the same reasoning in a new context. That's how understanding becomes transferable. So I want us to look ahead for a moment. Today's work sets us up for everything that follows. When students understand negative numbers as movement and distance, subtraction makes more sense, division becomes more intuitive, and soon ratios and rates will feel less abstract because students won't just be working with numbers. They'll understand where those numbers live, and that's the work of understanding math. Next time, we'll take this thinking into fractions and division and continuing to build the meaning instead of shortcuts. Same story, y'all. Deeper understanding. I'll see you in the next episode.